Hello everyone, and thanks for tuning in to the 13th and final Winter 2022-2023 update from GavsWeatherVids. So wow, here we go. We have reached the end of our journey, or we will have done when we complete this 13th and final video. And that's it. There will be nothing else that we can do other than release the winter forecast. And we will be doing that in 1 week's time, next Sunday on the 4th of December. So, pretty much at the end now. What an epic journey it has been. But maybe we'll say the best for last. We'll see. But, I've been keeping the video between 40 and 50 minutes throughout this season of winter updates. But on this one, I'm just going to let the running time go. I'm not going to worry about it. We're going to show you absolutely everything. It's going to be jam-packed full of information. You may have an information overload. Actually, there's so much information that's going to be contained within this video, and it is going to run well over an hour. I know that, just from getting it together, but I'm not going to worry about it because it's my final update, and we're just going to do it. So I shall get on with the video for you in a moment. Just say thank you so much to Siberian and Richard for all of the help on this video, and of course thank you so much to Richard for the incredible winter updates gift. This is my final time that you're going to see the winter updates gift, and also Roger the Robin, because we got a special gift for our winter forecast next week. So feast your eyes, everyone, feast your eyes on lovely little Roger the Robin, that probably isn't a Robin, but Roger the Bird. Feast your eyes on Roger the Bird. And thank you so much to Richard for the amazing winter updates gift. Everybody has fallen in love with this year's winter updates gift, so thank you so much, Richard. And of course, thank you to Shrine as well. When we get to the section that Richard and Shrine have helped with, of course, I will shout them out. So it really is a case of hashtag Team Gav. Of course, as always, Richard and Shrine, doing loads and loads of hard work and really making me look good, to be honest. So thank you so much to Team Gav. Right, so first thing I'm going to do for you is show you the swingometer. So King of Swing Richard has got the swingometer to us, and this is how our winter updates are looking as of the end of last week's 12th update. So after 12 updates, this is how the swingometer looks. Let's count it down. 3, 2, 1. Here we go. We're fighting back. We're fighting back. And there we have it. 52.5% to mild, and that means that we also have, if we can see it again, 47.4% to cold. So we are favouring a mild average winter after 12 updates by 52% to 47%, but that is a further swing from mild to cold from last week, and in fact in the last 2 updates, update 11 and update 12, that has generated over a 7% swing, the King of Swing Richard tells me, from mild to cold. So at the very end of our winter updates, we are seeing a swing here from mild to cold. Will that be enough after this week's update to get us to favouring a cold average winter by the time we do winter forecast next week? You will find out at the beginning of next week's winter forecast how the swingometer looks after 13 winter updates and 3 seasonal roundups. You will see the swingometer how it looks, after all of the updates at the beginning of next week's winter forecast. Goodness gracious me, what a dramatic start to this winter update. Thank you so much to our King of Swing, Richard Shaw, for that. Incredible and amazing. Wow. Here we go then, everyone. Let's crack on with update number 13, the 13th and final update. Let's start off with analogues. We're going to have analogues throughout this update, so they'll be coming and going in between all of the other regular days. We've got 4 analog sets to show you. Goodness gracious, we're going to begin with a little bit of November rainfall data. So up to the 26th of November, we have had 146.6 millimeters of rain for England and Wales, which is 138% of the average. So it will not be a top 10 wettest November, but more about that later on. But what we can see is that the anomaly to average has been wetter towards the southeast than it is towards the northwest, which is a little bit unusual. So our first set of analogues, fun little set suggested by Shrine, is looking at Novembers that are wetter in the southeast than to the north and the west. And there's a few of those, not many. The first one is 1970. November 1970 was wetter in the southeast than it was further north and west. And the winter of 1970-1971 looks like this, with above average heights to the north and below average heights to the south, winds in from the east. It has a cold December in 1970 with a white Christmas, by the way, but then it turns milder in January and February of 71. And then we've got November 1974. That was also wettest in the southeast. This one is a mild and dry winter, 74, 75, with low pressure rate to the northwest, high pressure to the south and southeast, and winds coming in from a southwesterly direction. That's a very mild winter. We've also got 1976. Goodness gracious me, that's shown up so often during this season of winter updates. So by the way, when we did winter forecast next week, you will find out which years have led with the analogues this year. So you'll find that out in next week's winter forecast as well. But November 1976 was wettest in the southeast compared to the northwest, and the winter of 76-77 looks like that is a cold start to winter, front-loaded winter, with a cold December, pretty cold January as well, and it gets very mild in February. Notice it does have a strong blocking seal around Greenland. It's a brutal cold winter for eastern parts of America, one of their most severest winters on record. For us, it starts cold and then it gets mild later on. We've also got 2003, so a long gap there. The next time November is wettest in the southeast, it's 2003. The winter of 03-04 looks like this, would be above average heights out to west. You think it's quite a cold winter, but it isn't really. There are a few cold snaps coming in going, but 03-04 isn't remembered as a particularly cold winter. And then we've got 2014, which of course is followed by winter 2014-15, which is like an average sort of winter with lower pressure to the north, higher pressure out to the west, and winds coming in from off the Atlantic. So a few cooler snaps coming in going with that one, but again, nothing overly dramatic. Right, so put all of that together then. So this is how all Decembers combined are looking. If we have a November when we've had a November that's wettest in the southeast compared to the northwest, a little bit of cold snap potential with those Novembers, I think. Got a mid-Atlantic ridge, winds in Decembers, I should say. This is how all Decembers combined are looking. A little bit of cold snap potential there with some higher pressure just out to our west when we have a November wettest in the southeast. This is all Januaries combined. Very, very unsettled for these Januaries with a deep trough of low pressure over Western Europe. So that's a really wet signal for the Januaries. All Februaries combined when November is wettest in the southeast. Looks like that. Very different with some higher pressures to the north of Scotland. A little bit of cold snap potential maybe for those Februaries. And all winters combined are looking like this, when November is wettest in the southeast. So we tend to get some higher pressure just out to our west, and lower pressure is to the east. Every month is very individual, so I'm not sure how useful the overall or winters combined chart is, to be honest, because every month is very individual and conflicting and contrasting. Thank you so much to Shryan for that set of analogues, for suggesting that set of analogues. And there's going to be analogues, as I say, coming and going throughout this winter update. So more to come. But let's move on to solar activity. So this is how the solar disk is looking on our side of the disk today from solarham.net. We've got a few sunspot regions, but despite that, solar activity is at low levels, and Solarham is reporting that for the next 3 days, solar activity is expected to remain at low levels. This is the final GavsWeatherVids Winter Updates Solar Activity Tracker, updated by Shrine Brown. Thank you so much, Shrine, for updating the tracker for the final time for these this season of winter updates. So we're at a lower level of solar activity, and it is being sustained actually now. So back around the end of September, we had this spike in solar activity up here, but since then the trend has been rather flat. We dropped down from that high level at the end of September into the beginning of October and went there, and since then, really throughout the rest of the autumn, we've just been hovering at that lower level of activity. Remember, the orange line, orange spots is depicting each individual day's worth of sunspot activity. So yeah, you know, we have not got back to that spike that we had at the end of September. We will, of course, at some point, but at the moment we're going through a slightly quieter phase in terms of overall daily sunspot numbers. Anyway, you can see how the green line, which is the 30-day average, is kind of flatlining after the drop that we had earlier on in the autumn. The green line, the 30-day average, is looking very stable. We will start doing a sunny roundups when we get into January. We'll do one sunny roundup a month, so you will see the solar activity tracker again in January, I would have thought, when we do the first GavsWeather sunny roundup. And we're hoping to do Solar Sunday as well, by the way, maybe in February. So there will be plenty more solar data to come. But for now, the winter updates, that's the final time that you'll see the tracker. Thank you so much to Shrine for keeping the solar tracker updated throughout this season. Now, who am I today? Let's have a look, 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 let's have a look. Oh, wow, wow, wow. Polar Express. I think on the conductor from Polar Express. How lovely! Thank you so much, Richard, for the lovely, lovely seasonal GIF here. Thank you so much, Richard, and for turning me into the conductor from Polar Express. I've never seen it myself, but it looks very nice and wholesome, doesn't it? Wide to the North Pole, of course. Right, thank you so much, Richard. So, for the final time, this is showing spotted days and the current spotted stretch. Final time for the winter updates. This is showing spotted days and the current spotted stretch. So, for the current spotted stretch, it is 0 days, given that we had sunspot yesterday, not surprising. And in terms of total spotted days for 2022, we have had 1 day without sunspots, which was less than 1% of the year. That is comparable to 2021, which had 64 days without sunspots, 18% of the year. And 2020, which had 208 days without sunspots, which was 57% of the year. Our solar minimum year was 2019, which had 281 days without sunspots. That was 77% of the year. The comparable year from the last solar cycle number 24, is 2011. Just here, that had 2 days without sunspots. Again, that was less than 1% of the year. The following year, 2012, and that will be the year we're comparing to next year, of course, in 2023, our comparable year in 2023 will be 2012, and that year had 0 days without sunspots. Every single day, all days in 2012 had sunspots. So if we start seeing days without sunspots next year in 2023, we will know that something strange is going on. Generally, we can expect the next sort of 4, maybe 5 years to have sunspots every day virtually. When we get into the second half of this decade, probably to around 2027, something like that, we will probably start seeing days appearing without sunspots once again as we start edging back towards solar minimum. But for now, we are in the maximum phase of the solar cycle. Thank you so much to Shryan and to Richard for all of the solar data during all of these winter updates. Wow, let's push on. So you're going to look at the QBO next, just to confirm that Westerly QBO is continuing. This is from NASA. So you've got to think that this is the atomic atmosphere in the stratosphere at 10 HPA. This is the boundary level of the atmosphere that we call the troposphere, 30 to 50 HPA, and this sandy brown area is the westerly QBO phase descending from the stratosphere down into the troposphere. So yes, it just confirms that the westerly QBO is in from the strat to the top. This will be a westerly QBO winter. We will have a westerly phase of the quasi-Siberian oscillation for the winter of 2022-2023. Of course, we looked at reanalysis earlier on in the updates to find out what that could mean for this winter. Now, the Arctic oscillation observed and forecast is looking very interesting. So the black line shows where we've been with the AO, the red lines of the GFS ensembles are forecasting the Arctic oscillation to go. Wow. And you can see that, yes, the Arctic oscillation currently is in weekly negative territory through most of the autumn. Certainly since October, the AO has been in positive territory, but the AO is weekly negative. And now look at this, the GFS ensembles are forecasting that the Arctic oscillation is going to stay in negative territory and may become even more negative as we go into December. Now, this is a flip on what we've seen over recent winters, because what's been tending to happen over recent winters is that we tend to have a negative AO, Arctic oscillation, through the autumn, and then sometime around the first day of December, it flips positive and stays there through the winter. Well, this time we're doing things a little bit differently. Now, it looks like the Arctic oscillation is going to be going into a negative phase through the early part of December. That tells that blocking is going to be increasing. Now, at the same time, the NAO is also on the move. So the North Atlantic oscillation observed and forecast looks like this, currently weekly negative, going to briefly go weekly positive, and then through the early part of December, go potentially quite strongly negative. So with the AO and the NAO here both trending into negative territory, this is a signal potentially for colder weather. We could start to see colder weather through the early part of winter. So the winter could get off, not necessarily going to last for the winter, and it's not winter forecast, that's coming up next week, but certainly for the early part of the winter, we could be starting off on a cold note, with both the AO and the NAO indexes telling us that there is going to be a blocking signal that could send the jet stream southwards. We might replace the Azores high with an Azores low and get some higher pressure around Iceland and Greenland, and the upshot could be that we have a cold start to the winter of 2022-2023. How exciting. Strat data next. So here we go from the JMA. The black line shows where we are, where we've been, where we are with the temperature at 10 HPA in the stratosphere over North Pole. The grey line is the trend for this time of year. You see, we're actually a little bit colder than average with the temperature at 10 HPA in the stratosphere over the North Pole at the moment, although we have had a little tick up in the temperature actually over the last few days, so we're not too far from average. If we go a little bit low down to 30 HPA, that's how we're looking, and at that level we're actually slightly above average now. We did go below average about a week ago, but now we're a little bit above the grey line, so nothing overly dramatic going on with the temperatures in the stratosphere over the North Pole at the moment. Let's see what the GFS parallel run is forecasting to happen with the temperature at 10 HPA over the next couple of weeks. So currently the blue colours here are the cold temperatures at 10 HPA, particularly over towards the Greenland and Canadian side of the Arctic. So there is a little bit of slight warming going on over Siberia right now. Let's see what happens as we run through. So certainly over the next week, those blue colours continue to sit there, the blues and purples continue to sit there over the Arctic and the North North Pole. Temperatures around mid-minus 70s, minus 75 to minus 80, something like that on the temperature scale. If we go back to 10 HPA, that will keep the black line somewhere around there, probably, so just a little bit below average, not overly dramatic. In the more extended range, this is how things are looking with the GFS parallel run. Again, the temperature's hovering somewhere between around minus 75, minus 80 over North Pole. But notice, of course, significant warming of the stratosphere predicted by around the 8th of December over Siberia. Now, this is not a sudden stratospheric warming, but it's not reaching that sort of level. But it is quite a significant warming of the stratosphere going on over Siberia there. And it is very early days to be seeing that, you know, very early in the winter to get that kind of quite substantial and significant warming. It actually goes around minus 16 around the 9th of, the temperature goes minus 16 there around the 9th of December, which again, it is a very substantial warming of the stratosphere being predicted there, not quite reaching sudden stratospheric warming levels, but certainly, you know, quite significant, that warming, and early days to be seeing that. So interesting developments stratosphere-wise. Could that eventually push it into a genuine SSW a little bit later in winter, say around Christmas and New Year? Makes you wonder, doesn't it? Certainly in terms of the zone of wind forecast from ECMWF at 10 HPA and Saturday North Pole, not much sign of a sun stratospheric warming up to the beginning of January. So at the moment, actually, zone of winds are a little bit weaker than average. See the blue line underneath the red line, see the trend. At the moment, the zone of wind, remember, zone of wind is telling you how strong the polar vortex is, basically, at its root. So we're a little bit weaker than average with polar vortex at the moment, but it is going to strengthen by the look of it into early December, which is interesting, this, because that's when the blocking signal is increasing. We know that via BAO, you know, but in the troposphere, but we're going to have an increasing blocking signal. But in the stratosphere, at 10 HPA, you know, in the stratosphere, actually solar winds are strengthening. So obviously it's going to be a bit of a decoupling, actually, between the troposphere and the stratosphere, which is quite interesting. That is something that can occur. That happened in December 2010, for example. There was no warming of the stratosphere and no reversal of the solar wind in December 2010, but nevertheless, we managed to get a large amount of northern blocking in the troposphere, and that's what delivered us, you know, for December to remember. So it's not always the case that to get very cold, blocked, northern blocking type conditions, that you have to have a sudden stratospheric warming and a reversal zone. Sometimes you can actually get a decoupling between the stratosphere and the troposphere. The forecast keeps the zone of wind stronger than average then through the first half of December, maybe dropping a little bit later on towards the end of December into early January, but not much of a sign of a sudden stratospheric warming. No sign really of a reversal of zone of winds there up to the beginning of January. Remember, it's only a forecast though. Let's drag this over here. So these are the temperature anomaly predictions for the North Pole over the next 6 weeks from the ECMWF. At the moment, because we've got these blue curves, so quite cold temperatures there. If we go on to week 2, there's that significant warming of the stratosphere over Siberia that I was just talking about. So ECM is also picking up on that, not reaching sudden stratospheric warming levels. Let's just put the scale on. Not reaching sudden stratospheric warming scale, but that is a significant warming there over Siberia. That sort of pushes round towards the Pacific side of the Arctic for week 3, beginning to displace the polar vortex a little bit, maybe a little bit of a displacement event might be the upshot of that warming, with the core of the polar vortex going more towards northern parts of Europe, but not, you know, not able to destroy the polar vortex, so not reaching sun stratospheric warming levels, not reversing the zone of wind and whatnot. As you go through weeks 5 and into week 6, again, there's not much sign that we're going to see a sudden stratospheric warming up to like week 6, which is the 2nd to the 9th of January. That's getting us in towards the middle part of the winter, of course. But we should wait and see. We should wait and see what happens. So the development at the moment with that quite significant warming over Siberia is similar to what happened in December 1984, actually. So I thought we'd have a look at a little bit of archive data for stratospheric temperatures. This is the 1st of December 1984. You see we've got these blue curves here over the Arctic and over the North Pole. Let's go on to, say, the 10th of December, and you see quite a significant warming took place with the opening days of December 1984 over Siberia. Did displace the polar vortex at its roots a little bit. Again, that does not reach southern stratospheric warming temperature requirements levels, but quite a significant warming taking place there through the first 10 days of December 1984. That sort of fades out and the polar vortex sort of re-strengthens, but then look what happens as we get towards Christmas of 1984. Then we start stretching out the polar vortex a little bit of warming over Siberia, another warming in the North Atlantic, and look what happens as we move on towards the closing days of December 1984, a very significant southern stratospheric warming begins to take place, unusually, in recent years anyway, over North America and the North Atlantic. And eventually, this warming of the stratosphere did completely destroy and obliterate the polar vortex. So by New Year's Eve of 1984, there we go. We've got a complete split of the polar vortex, obliteration, and very, very, very substantial and significant warming of the stratosphere. So did that little pre-warming in early December of 1984, did that, soften up the stratosphere ready for that major southern stratospheric warming that occurs around and after Christmas to New Year of 1984. Of course, that was a very, very cold winter. I thought we'd have another look at a Westerly QBO winter, which is 1990-1991 from a stratospheric perspective. So again, we've got these blue and purple colours here on the 1st of December 1990, polar vortex at its roots. Now with this one, the stratosphere stays pretty cold, although there is a slight warming there over Siberia, but the stratosphere stays pretty cold throughout most of December of 1990, right the way up to New Year's Eve. We have got a bit of stretch of a polar vortex going on there on New Year's Eve, but basically not much in terms of a warming of the stratosphere through December 1990. What about January? So let's go here. What about January of 1991? Let's have a quick look at that. And you can see that as we get into 6th of January, we get quite a significant warming again of the stratosphere occurring over North America and North Atlantic. We don't tend to see that very often these days, the warming starting over there. Normally the warming now happens over Siberia, but back then, in January 1991, yes, we do see quite a significant warming of the stratosphere there, and that kind of fades out. Those go to 16th of January, that one kind of fades out as well, but does that sort of set things up for what happens later on? This is 23rd of January. Notice, quite significant warming taking place over the Pacific side of the Arctic and of the North Pole. And as we go on into the end of January, well, then we get a major southern stratospheric warming occurring over the North Pole and over Siberia itself. So there is a major southern stratospheric warming that takes place during the winter of 1991. This is a Westerly QBO winter as well, of course. So a very, very substantial southern stratospheric warming takes place before the freeze-up of February 1991. And what about the daddy of cold winter, 62, 63? Let's have a quick look at that. So again, start of December, blue colours there, polar vortex at its roots in the stratosphere. Let's go to when the big freeze is starting on the 26th of December on Boxing Day. And look at that, no particularly noteworthy warming of the stratosphere taking place there. So obviously again there must be a decoupling going on between the stratosphere and troposphere. There was a warming of the stratosphere at 30 ppm in November of 1962 though, actually, but it's not until we get into January, I don't think, of 63, but we get a major southern stratospheric warming. Look at that, major southern stratospheric warming by the 26th of January 1963, just keeping the cold winter going. Split of the polar vortex, you will notice two lows of the PV, one over towards the Pacific and one into northern parts of Europe there. So So yeah, you know, you can get it cold without these sun-stratospheric warnings. You can get a decoupling of the stratosphere and the troposphere, and sometimes like an early warming that doesn't reach SSW levels, but a significant early warming, such as we might be going to see in around sort of 10 days' time in Siberia. Sometimes that can be a precursor to very cold, you know, sun stratospheric warming. Can't leave this without showing you January of 2013, of course. So look at this sun stratospheric warming that happened there. 1st of January 2013, sun stratospheric warming taking place over Siberia, leading a few days on to a very significant warming of the stratosphere penetrating into the Arctic from Siberia, and a few more days on still, leading to a split of the polar vortex and a total obliteration of the PV. There you see it, total obliteration of the PV through the first half of January 2013, which of course we know that did eventually find itself translating back into a cold winter. That's our last properly cold winter, I think, 2012, 2013, and a severely cold March. Right, I hope you enjoyed that look at the stratosphere, a little bit of stratosphere special for that section. Let's do some more reanalysis, let's do some more analogues. So, having a very, very mild, very warm autumn. This is central in temperature for September 14.4, October 12.8, November 9.6. This will be a top 10 warmest autumn since 1950. It will probably be top 3, actually. So we're going to count down the top 10 warmest autumns and the winters that follow them. At number 10, we've got 1995. The winter of 1995-1996 was a cold winter with high pressure to our north and low pressure to the south, and winds coming in from the east. Cold with east winds on and off throughout that winter. At number 9, we've got 1978. Winter of 1978-1979 is a winter of discontent. It has blocking over Greenland, Iceland, low pressure to our south. Jet stream is pushed southwards as well, and winds are in from a cold easterly direction very often through that winter. Very cold winter, and the last time we had a sub-zero CT January as well. At number 8, we've got 2001. The 8th warmest autumn was 2001. The winter 2001-2002 looks like that. Chart doesn't show you everything you need to know about that winter. It has quite a coldish December, and then it gets milder later on in the winter. At number 7, we've got 2009. Winter of 09-10 has blocking within high latitudes. Low pressure is pushed southwards along with the jet stream as well. Winds are coming in from the east. That was a cold winter for 2009 and 2010. At number 6, the 6th warmest autumn was 2002. Winter of 2002-2003 looks like it should be a cold winter with high pressure around Scandinavia and winds in from the east. Actually, it wasn't a particularly cold winter, but there were a few colder snaps. At number 5, we got 1959. The winter of 1959-60 was a mild and wet winter to start off the cold decade of the 1960s. At number 4, we've got 2021. Last autumn was the 4th warmest autumn, and this one is a mild winter, of course, with high pressure over to the west of the country. Quite a cold winter for northern and northeastern Europe, though, that shot of low pressure, but we're always on the periphery. Generally mild, at least after Christmas. At number 3, we've got 2014. Winter 2014-15 is about average temperature-wise and rather Atlantic-driven. A few cold stats, but nothing particularly exciting. Number 2 is 2011. The second warmest autumn is 2011, with high pressure out to west during this winter, and low pressure is across eastern Europe. So a very, very cold, brutal cold winter for the Balkans and eastern parts of Europe. For us, actually, we have quite a mild winter, but there is one really cold spell in early February. And then at number 1, the warmest autumn since 1950 anyway, is 2006, and the winter of 2006-2007 is a mild and dry winter with high pressure to the south and low pressure is up to the north, winds coming in from off the Atlantic. That's a mild winter for 06-07. So putting all Decembers together, this is how they look after the top 10, following the top 10 warmest autumns. Quite a significant blocking signal for these Decembers, interestingly, and lower pressure to the south. So there is a bit of cold potential, actually, for those Decembers, although they do look quite unsettled. All January's combined, also showing a bit of cold potential, with some high pressure blocking around Greenland and Iceland. Lower pressure is over and to the south of the country. And all February's combined, still with that blocking signal there, but more towards the Canadian side of Greenland. So maybe by then favouring like a milder outcome. And then lastly, all winters combined, following the top 10 warmest autumns, we look like that. It could be a signal for a cold winter with a lot of these winters. High pressure blocking around Greenland. Perhaps going to send that chop of low pressure a little bit further southwards. But overall, not too bad if you would like a colder winter outcome. Right, I think we have a little pause there. It shows you lots of data. We've still got so much more to come. This video is going to run over an hour easily. So I'll pause the video there. You go off and stretch your legs. And when we return, we're going to have loads more data to come. So I'll see you very soon. Okay, we're back and we're ready to resume the epic 13th and final winter 2022-2023 update from GavsWeatherVids. Wow, what an epic it's been, and we've still got so much more to show you. We're going to be bringing you sea surface temperature anomaly data next for the next thing that you're going to see. Thank you so much to Schreier for the analogues that we just saw at the end of the first section of this winter update. Thank you so much to Richard for the amazing winter updates there. Thank you so much, Rich. We're walking in the air. We're floating in the moon sky. There's actually a tune that plays with that, but I've been muting because I don't want to get the video to demonetize. But yes, this GIF actually plays. We're walking in the air. So I can't do it as well as Ali Jones, though, I don't think. Although he can't sing either, can he now, since his voice broke. Anyway, thank you so much, Richard. And also Roger the Robin, of course. Right, sea surface temperature anomaly date. Goodness, good. This video, isn't it? I hope you're enjoying it. Sea surface temperature anomaly data next. So this is how the oceans were looking when we did last week's 12th winter update. 4 areas of interest. We've got the ENSO region just here. We've got the Indian Ocean over there. We've got the Northern Pacific and Northeast Pacific just there. And then we've got the North Atlantic over here. How do we compare? So in terms of the ENSO region, not much change actually. Since last week, the signature for La Nina continues, and we continue to see that it's coldest in the eastern portion of the extra-Pacific Ocean, so this remains and will remain an eastern-based La Nina. Going further northwards, let's go back to last week, then forward to this week in the North Pacific. We've possibly lost that cooler signal here in the northeastern Pacific. That's quite disappointing. It's still a little bit cooler than average in the far northeastern corner of the Pacific Ocean, but you'd expect that to be strengthening really in response to the La Nina. So that's struggling to get that going. Over in the Indian Ocean, that situation last week, that situation this week. Over in the Indian Ocean, not much change, really. We're going towards a neutral IOD. And in the North Atlantic, again, that's how it looked last week. This is how it looks this week. Again, not much change in the North Atlantic. Turned a little bit cooler through that area, possibly through the tropics as well. Generally quite warm through there and up there too. We have not got a tripole, so this is going to be another winter without a tripole. This is the 7-day trend, or 7-day change. So in terms of the ENSO region, that's how it looks. Generally it's warmed a little bit through the ENSO region, but some of these eastern portions are still cooling. Northeastern Pacific, you'll notice that's warmed slightly over the past 7 days. North Atlantic appears to be cooling, especially over towards Newfoundland. If you get colder down the eastern seaboard of the United States, that might start moving us towards a tripole. Notice the tropical Atlantic has cooled slightly too, and the Indian Ocean generally warming up a little bit. In terms of ENSO, just to confirm that La Nina will continue through this winter. This is region 3.4 forecast from CFSB2. Temperature is on the side, dates much appears along the bottom. So we're going to be under half a degree below average. That's La Nina threshold through into January. This will be La Nina winter. It will also be an eastern-based La Nina, given that regions 1 and 2, which is the eastern portion of the equatorial Pacific Ocean, just here are colder, showing colder than average temperature anomalies compared to 3.4. So this will be an eastern-based La Nina winter. Southern Oscillation Index looks like this. The SY index reflecting atmospheric state, measuring air pressure between Darwin and Tahiti. When it's positive, when the SY is positive, the atmospheric state will be reflective of La Nina, and the SY is negative, the atmospheric state will be reflective of El Nino. You can see the two columns for Tahiti and Darwin just there, and then the overall SOI number is calculated just there. Generally still positive with the SY most days. 18th of November plus 11, 19th of November plus 9, 24th of November plus 11, etc. I want a negative day creeping in. 22nd of November down to minus 6. 26th of November down to minus 4. So maybe we're seeing signs of the atmosphere beginning to shift a little bit more towards an El Nino type state, and that will bring an end to the La Nina course. So you'd expect that really as we go further on into the winter. It might be a little bit early for that. The 30-day SOI average, which is this red line, is reducing from its very positive level, but it's at in October. We're now just there. So maybe the SOI is beginning to shift from that strong La Nina type setup. In terms of the Indian Ocean dipole, just to confirm that we are going to see a neutral IOD after having a very negative Indian Ocean dipole through the summer and into the autumn. So the forecast probabilities are for a neutral IOD in December. 94% chance of a neutral IOD in December. 93% chance of a neutral IOD in January. And 79% chance of a neutral IOD in February. Though, yes, it's going to be like a neutral IOD, a winter, after being negative, through the summer and into the autumn. Connected to seaside temperature anomalies, of course, is what's going on with the Atlantic hurricane season, what has gone on, given that we're pretty much at the end of it now. So for the final times, these are the scores on the doors for this hurricane season. We've had 16 tropical depressions, we have had 14 tropical storms, we have had 8 hurricanes, we had 2 major category 3 or above hurricanes. That is unchanged from last week. ACE for this season looks like this. ACE Master Shrine has been keeping the ACE updated for us throughout this season. Thank you so much, Shrine, for keeping ACE updated. Let's have a look at it for the final time then. If we come down here, we can see that this season ACE is standing at 95.10. I think that is unchanged from last week. That is after 14 tropical storms, 8 hurricanes and 2 majors. We would expect to have had an ACE of 121, so we're near normal. We're categorised as near normal, but as we explained with last week's reanalysis, we are at the lower end of normal, and we explain what that look like in terms of the analogues. We'd have expected to have 14 tropical storms, so that's in line. We're expected to have had 7 hurricanes. We actually had 8, so a little bit above for that. And we'd have expected to have 3 majors. We've had 2, so a little bit low on the major hurricane side. Thank you so much, Shryan, for that. Thank you so much to the Ace Master. We're going to do a comparison for the final time for Atlantic Sea Survey temperature anomalies, see which years we closest to. So I want you, please, everyone, to ignore anything from here onwards. We're focusing just there. Feast your eyes. That's the current set up in the Atlantic. Let's quickly go through. So compared to 2021, how are we looking? I think 2021 actually was a little bit warmer at this point. That's 2020. How do we compare 2020? I think that's a little bit similar, actually. There could be a bit of similarity there. Please let me know in the comments which years you think the closest to. I think 2020 could be a closer year. That's 2019. How do we compare to that year? That might be reasonably close as well. That's 2018, which is a cooler year, so we're warmer than 2018. That is 2017. Worrying about that year, probably a little bbit cooler than that, but it actually has cooled down a bit over the past couple of weeks. That's 2016. Notice the cool blob there. So we are warmer than 2016. That's 2015 again. We're significantly warmer than 2015 with the North Atlantic. That is going to be 2014. Again, we're cooler in 2014 than this year. That's 2013. I think we're cooler in 2013 than this year. That is 2012. What do you think about that year? That could be a slightly closer year. That's 2011. So cooler in 2011 than this year. That is 2010. 2010 has much more of a tripole type situation, much warmer in the tropical Atlantic. That is 2009. Again, what do you think about that year? That could be a close-ish sort of year, but I think it's cooler around Newfoundland. 2009. 2008, not much comparison this year to 2008. 2007, again, not much comparison this year. 2007. 2006, that could be a slightly closer year, maybe. Again, please let me know in the comments, everybody, which years you think are closest. That's 2005, so I don't think there's much comparison this year. 2005, especially for tropics. That's 2004, again, not much comparison. That's 2003, and again, I don't think we have all that much comparison there. That's 2002. The Atlantic beginning to get colder now as we're going further back, so no comparison this year. 2002, not much comparison to 2001, not much comparison to 2000 either, or 1999. 1998, what do you think about that year? Again, I don't think there's much comparison this year. 1998. 97, now we're moving back into a colder era for the oceans generally, and for the Atlantic too. 1996, again, no comparison. 1995, what do you think about that? It's much more this year than it was in 1995, although we did have a bit of a tripole type signature, actually, in 1995. 1994 looks like that again, not much comparison. 93, now we're going back into much cold AMO periods. 1992, no, none of these years are going to be comparable, really. They will all be colder. 89, 88, 87. Look how cold it is in at this point in November 1986 in the North Atlantic. Absolutely no comparison at all. That's the last year, 1985. Let me know in the comments, everybody, which years you think we're closest to there. That's the last time you're going to do that. Right, more analogues. Wow, wow, wow. What an update this is. Unique content, everybody. I hope you're enjoying it. So the next thing we're going to be looking at is England and Wales rainfall for November. So as I said earlier on, up to the 26th of November, England Wales precipitation is looking at standing at 146.6 millimetres, 138% of average. So we're going to be looking at winters following November's with an England Wales precipitation range of 130 to 170 millimetres. We're expecting to come out around 150 millimetres for this November. So the first winter is 1951 with low pressure over and to the south of the country, high pressure in the middle of the Atlantic. That has a cold December in 1950, and then it gets much milder later on. Thank you so much to Shrine for getting these years together for us. Our next winter following November with an England Wales precipitation range of 130 to 170 millimetres is 1955. This is a cold winter, high pressure blocking within the high latitude, low pressure to our south and east winds only come in from a north or a northeasterly direction. Let's shut down these tabs. Our next winter is going to be 1961 following November 19 60 with an England Wales precipitation range of 130 to 170 millimeters. This is a mild, wet winter, but I think it does have some colder weather in December. And then we've got 1963, 1964, which is a dry winter, high pressure in control, anticyclonic, very quiet winter following Madani of cold winters. Then we've got 1969, 1970 with low pressure to our south, high pressure is to the north. That gets much colder later on. And then we've got 1974, 1975. Again, that was earlier on. It's a mild and dry winter, especially so for more southern areas. Winds in from the southwest. The great drought begins there. We've got 84, 85. This is a genuinely cold winter. 1984, 1985, high pressure blocking within the normal latitude, low pressure, more southwards winds coming in from the east. That gets very cold in January and February, follows that big sun stratospheric warming, of course, at the end of December 1984. We've got 1992, 1993. This is a mild and dry winter for this one. And then we got 2012, 2013, and that follows the big sun stratospheric warming at the beginning of January, of course. And this one gets colder as it progresses, culminating in an extremely cold March. We got 2019, 2020, that's the polar vortex of doom. So if you want a cold winter, you don't want to see that one showing up. But there it is, PB of doom, very mild, wet and stormy winter. Right, let's put all of that together then. This is how all Decembers combine, looking following November's with an England Wales precipitation range of 130 to 170 millimeters. Lower pressure around the country, was quite unsettled for the December, but kind of a bit of a southerly tracking jet stream, so not a straightforward zonal signal. That's how all January's combine, looking following November England Wales precipitation range of 130 to 170 millimeters. Again, quite unsettled, low pressure in off the Atlantic Ocean. Not a straightforward zonal signal though. All February's combined look like that. Again, low pressure is in off the Atlantic. It does have a bit of blocking around Iceland though. And then all winters combined following England Wales November precipitation range of 130 to 170 millimeters. Looks like this with low pressure to the south and over the country. Not a clear-cut zonal signal that, but overall probably favours like a mildish and quite wet winter. Right, lastly for this section, we're going to have a look at Eurasian snow cover. So this is how Eurasian snow cover for the final time this season. And again, thank you so much to Shrine for suggesting those years. I get most years together for us. Right, Eurasian snow cover for the final time this season. This is how Eurasian snow cover was looking last week when we did the 12th update. So we had got the snow line into Europe. This is how it looks now. There we go, very little change, except that the whole of Scandinavia is now covered, so big gains in snow cover across Scandinavia, and we have retained the snow cover into eastern parts of Europe as well. So we've lost a little bit patch from Poland, but really Eastern Europe still relatively snow cover, and virtually the whole of Scandinavia is snow cover. Big gains in Scandi. Right, let's see how we compare them. So do the comparison for the final time. So we have more snow cover across both Russia and Scandinavia this year than we did in 2021. We have more snow cover this year than 2020. We have more this year than in 2019. We have more this year for Scandinavia than we did in 2018. Probably reasonably comparable for Russia and Eastern Europe. We have more snow cover than we did at this point in 2017. We have more snow cover than we did at this point in 2016 too. We have more snow cover than 2015. And we have more snow cover, significantly more snow cover than 2014, not only across Europe and Scandinavia, but well into Russia. Look at that, look at the difference between this year, 2014. More snow cover than 2013 as well, especially for Scandinavia and also for Russia and Eastern Europe. More snow cover than 2012. We're doing great for snow cover compared to these years. So more snow cover than 2012, more snow cover than 2011 as well. That's 2010. So Scandinavia was covered at this point in 2010, interestingly, but most of Europe and western parts of Russia, we got more snow cover this year than in 2010. More snow cover than in 2009 as well, very substantially so. 2008, now we have less snow cover this year across Europe than 2008, but we have more snow cover for across Scandinavia this year than 2008. So you pay your money and you take your choice with that one. 2007, we have more snow cover across Scandinavia this year than 2007. Probably quite similar for Europe and Russia. We have more snow cover across Scandinavia and Europe this year than 2006. 2005, we have more snow cover across Scandinavia and Western Russia than this point 2005. However, we have more snow cover 2005 than this year across Europe. So that's a very strange one. 2004, more snow cover across Scandinavia this year than 2004. Probably a little bit less for Europe and Russia though. 2003, we have more snow cover this year than 2003, 2002, there we go, we have more snow cover this year than 2002 at this point. 2001, we also have more snow cover, particularly over Scandinavia, than this point, at this point when we did them. 2000, we have more snow cover this year than in 2000. 1999, we have less snow cover, substantially so, across Europe, but probably a little bit more across Scandinavia. 1998, again, probably less snow cover across Europe and also Scandinavia than this point in 1998. Let's go in further back than that. For the final time, we'll look at Rutger Snowlab. We won't do a comparison, so just feast your eyes on that. Envisage that Scandinavia is pretty much entirely snow covered now, and the snow line is sort of into Poland. Right, so how do we compare with 1997? So we probably have less snow cover this year than in 1997. 1996, we have more snow cover than in 1996. 1995, we probably have a little bit more snow cover across Eastern Europe and Western Russia than in 1995. 1994, I think we have more snow cover into Scandinavia and Europe this year. 1993, though, we are behind for Europe, but we're ahead for Scandinavia. 1992, we are ahead, I think, for Europe, a little bit anyway, but probably behind for Scandinavia and Russia. 1991, we're ahead of 1991. We're well ahead of 1990 in all areas. We're behind 1989 for European snow cover, but a little bit ahead for Scandinavian snow cover. 1998, probably quite comparable for European snow cover, but behind Scandinavian snow cover. 1987, probably quite comparable for European snow cover. We're ahead this year, though Scandinavian snow cover, we're ahead of 1986. 1985, again, we're ahead of 1985 for Scandinavian snow cover at this point, probably comparable for European snow cover. 1984, we're ahead of 1984. 1983, we are ahead of the Scandinavian snow cover. 1982, we're ahead of. 1981, probably quite close to this year. 1980, I think that one, again, let me know in the comments, everybody, which is you think they're closer to. This is all subjective in my opinion, so please let me know in the comments. 1980, I think we're ahead of 1980. Snow cover 1979, well ahead of that year. 1978, wow, look at that. Just for a really cold winter, we're ahead though this year for snow cover. 1977, probably a little bit ahead of that year, especially Scandinavian snow cover. 1976, ahead of that year. 1975, ahead of that year. 1974, we're ahead of that year. 1973, ahead of that year. 1972, probably ahead of that year. 1971, that's closer. 1970, again, probably a little bit ahead of that year for European snow cover. 1969, we're ahead of that year. 1968, probably a little bit behind that one for European snow cover. 1967, we're ahead of that year, I think. And 1966, finally ahead of that year. And that's it for Eurasian snow cover for this season. the fan favourite, or one of the fan favourites. Right, one last stoppage, and when we come back, we've got a final set of analogues to show you, and then we are done with our winter updates. So I'll just pause the video there, and I shall see you in 2 seconds. See you very, very shortly. Okay, here we go, the final section of the 13th and final Winter 2022-2023 update. It's been epic so far. We're around an hour. We've got a little bit more to show you. Actually, it's a shorter running time than I was expecting, to be honest, this. I think it's going to go to around 1 hour 15 minutes, but I've managed to get through it a little bit quicker than I thought. But I hope you enjoyed this epic final update. Thank you so much to Shryan and Richard for all of the help on the video up to this point. Thank you so much to Richard for the amazing winter update skin. And we're going to show you one final set of analogues, and then we are done with this season of winter updates. Goodness gracious me, and the final set of analogues is going to be looking at the November central in temperature. So the CT for November provisional to the 25th is sitting at 9.6. That's 3.1 degrees above average. So this is going to be definitely within the top 10 mildest Novembers on record, and so we're going to look at winters following the top 10 mildest Novembers for the final set of analogues for this update. So at number 10 we've got November 1978, the winter of 1978-1979. Saw it earlier on, of course, is the very cold winter of distant temp, low pressures, and the jet stream down towards Spain, high pressure blocking around Greenland, Iceland, winds in from the east. The last time we had a sub-zero January CT was in 1979. I was 2 years old. That's how long it has been. At number 9, we've got 2002. We saw that one earlier on too. Winter 02-03. Looks like it should be cold, but it is not. There are a few cold snaps coming and going, but not particularly cold to that one. At number 8, the 8th mildest November is 2020. The winter of 2020-21 is the famous teaser winter. Goodness gracious, lots of blocking to the north, but this trough of low just doesn't go quite far in the south to allow those cold east winds in, although it is a cold winter across Scotland. Winter is coming! Wow. At number 7, we've got 1953. And the winter of 1953-1954 gets cold later, with high pressure over Scandinavia, and winds are coming in from an easterly direction. Cold February there. At number 6, we've got 1951. Winter of 1951-1952 is an unsettled winter with some cold snaps coming and going. At number 5, the 5th mildest November, it's 2014. Winter 2014-15 has shown up a lot in this final update, with low pressure to the north, high pressure to the west, winds in off the Atlantic. That's an average winter with a few cold snaps here and there. At number 4, we've got 2009. That one showed up later on. 09-10 was a properly cold winter, blocking around Greenland, low pressure, and the jet stream for southwards. Of course, that is a winter occurring very close to solar minimum, though. Excuse me. At number 3, we've got 2015. The winter of 2015-16 looks like that, with low pressure away to the northwest, high pressure to the south, the winds coming in from west or southwest direction. Exceptionally mild winter 2015-16. At number 2, we've got 2011-2012. And by the way, winter is coming. Have I mentioned it? I don't think I have. A winter of 2011-2012 has a deep trough of low pressure into Eastern Europe. Really cold winter for the Balkans. And then at number 1, the mildest, warmest November on record is 1994. The winter of 1994-1995 is a mild winter with high pressure south, low pressure to the north, and very stormy winter, but with regular cold interludes in the northern half of the country in January, but otherwise it's a pretty mild winter, to be honest. Right, put all that together. This is how all Novembers combined are looking following the top 10. This is how all Decembers combined looking following the top 10 mildest, warmest Novembers, and we have high pressure to our east, low pressure is out to west, a relatively unsettled and mildest signal for those Decembers. All Januaries combined, following the top 10 mildest Novembers, looks like that, with high pressure blocking in the northern latitudes and the mid-Atlantic ridge. Low pressure gets sent to our east. Definite cold snap potential for those Januaries. All Februaries combined, following the top 10 mildest Novembers, has blocking around Greenland. Low pressure to the south, winds tend to be coming in from the east. So again, cold snap potential definitely for those Februaries. And all winters combined, following the top 10 mildest Novembers, looks like that, with again high pressure blocking around Greenland and within northern latitude, low pressure over UK and western parts of Europe. You could envisage that at least quite a few of those winters are delivering colder conditions potentially. Now, we've only been looking at years from 1950 onwards for this season of analogues, so I'll let everybody know, whether we're going to carry on doing that, whether we're going to go back and look at years further back. But I thought, just to end this, we might go a little bit further back, because there are actually 4 other Novembers in the first half of the 20th century that had 8 Celsius CTs or more. That's 1913, 1938, 1939 and 1946. So just as an addition, this is how the winter of this is not going to, these years aren't going to be placed within winter forecast, but I thought just as an addition to end with, this is how winter of 1913, 1914 looks, following a very mild November. This one is a mild and wet winter, with winds coming in from off the Atlantic. This is how 1938, 1939 looks, following an exceptionally mild November. Low pressure to our west, a little bit of high pressure in north latitudes. The thing with that winter is that has a very cold December, with a classic white Christmas. 1939-40, of course, is the severely cold winter, first winter of the Second World War. Severely cold sub-zero CT January. First time we have a sub-zero CT month since February 1895. Jet stream is sent down to Spain. High pressure blocking around Greenland. Winds in from the east. Severely cold winter 1939-1940. And then, of course, we have November 1946, and the winter of 46-47 is an exceptionally snowy and cold winter, with high pressure blocking within the high latitudes, low pressure over to south of the country, winds in from the east. That's a really severely cold and snowy winter in 1947. All Decembers combined for those additional mild November years look like that. Definite cold potential. High pressure blocks around Svalbard. Low pressure to our south, winds in from the east and from the northeast. All Januaries combined looks like that. Hang on, no, that's wrong. I'm in the wrong order there, aren't I? So what am I doing? So that is January to December. Oh, right, well, that should be all Januaries combined, but never mind. It has like a blocking sort of signal. Anyway, with low pressure south, high pressure north, winds in from the east. That is all Februaries combined. That one has a strong blocking signal around Greenland, a little bit of lower pressure coming in off the Atlantic, and that is so I know what's happened there. That's saying all December to February as well there. So what's gone on with that? It's all turning to a little bit of a mess right at the end. Never mind, this should be all Januaries combined. Anyway, I don't know what's happened, but that should be all. Oh, that's January to December, so that's like a yearly thing, isn't it? What have I done there? Right, so that's January to December. Forget that one then. That's like a yearly analogue. Right, so I shouldn't have gone off on this tangent, should I? This is all February's combined. Blocking up there, low pressure just there. Maybe slightly less of a cold signal for the Februaries, and all winters combined for those additional years. You get the idea. High pressure blocking within the north latitudes, low pressure south, winds in from the east. I shouldn't have gone off on that tangent, but there we go. Right at the end, I've messed it up, but never mind. That, ladies and gentlemen, is your 13th and final Winter 2022-2023 update. Wow. We're coming up to 1 hour 10 minutes. What an update. And although it went a little bit wrong at the end, to get the idea that those earlier very mild Novembers can be followed, of course they can, by by colder winters. So what does this do for us? What does this final update do for us in terms of the winter forecast, in terms of the swingometer? You're going to find out in 1 week's time. So next Sunday, 4th of December, we will be releasing our winter forecast. We're going to begin that winter forecast of course, with the swingometer, so you will find out how this update has affected the swingo, if it has moved it at all. That'll be the first thing you see. We will show you which years are leading to have led in terms of this year's winter updates, and we will then give you the forecast. So stand by, everybody. The winter 2022-2023 forecast is imminent and will be with you in 1 week's time. Thank you so much to Shryan for that earlier set of analogues. Thank you so much to Shryan and to Richard for all of the help on this winter update. Thank you so much to Rich for the amazing winter updates gift. Thank you so much to all of you for sticking not only with this epic and very, very, very long winter update, but for the whole season of winter updates. It's been a long season. We started at the beginning of September. Been 3 months of winter updates, but here we are. We've reached the end of our journey, and now the payoff. Now the winter forecast in 1 week's time. If you have enjoyed this 13th and final winter update, then please like, share, subscribe, all of that good stuff. We thank you so very much for doing that, and we're going to see you in a week's time for our winter forecast. We will be discussing this winter update in our live stream tomorrow, Monday, at 8 p.m. So if you've got any questions, then let me know tomorrow on the live stream. And yes, winter forecast 1 week today. So stand by, everybody, for the 13th and final winter 2022-2023 update from GavsWeatherVids. That's all for now, and thank you so much for watching. Bye for now.